when I want to say that it was on a Math 8 assessment, but it might have been on a Regents exam. I don't remember which. They gave you this question that we're about to talk about, and it was like brutal. If I remember right, I want to say out of approximately 30 kids, and I believe in an accelerated class, I'm not sure, I think it was accelerated, I think maybe 2 got it right. They had never done a question like this before, where you needed to use the Pythagorean theorem twice in order to get it right. Now, once I showed it to my kids, from that point forward, I've gone over a question like this every single year when we do Pythagorean theorem. And then kids get it right all the time. But if you've never seen it before, it's extremely difficult to see what's going on. Also, back in the day, we didn't have smartboards when this question came out. So we would have to draw everything with chalk. And it took you a little more time to draw with chalk. But it also, unless you had colored chalk and you really got into it and took your time, it was a little bit difficult to draw this particular diagram on the board. And it's still a little difficult. I'm going to try to do it right now and take you through how to understand this question. Now, if you walk out of here and you say, man, that do it question, that was brutal, we're going to have it on a couple of do it's in a row, like 3 in a row. So don't panic if you don't get it today. And if you do walk out of it saying to yourself, man, I can do that, that's an awesome sign, because this is a very, very challenging question. Okay. Let's go through this step by step. And I think it helps to use the smaller pen. So, let's see here. Okay, so that is a right rectangular prism. And within this prism, there are 2 different rectangles, or right triangles, I'm sorry. 2 different right triangles being drawn. One goes across the bottom here, and this side has a length of 3, and this side has a length of 4. Then, there's another one, this is the beauty of having different colored pens here, that goes from the top down. This is like the straw problem from yesterday. But the straw problem, we didn't have the red one, we just had the blue one. And it wants you to find n, and it tells you that this is 12. And now the question is,
there's no right angle.
actually there are a bunch of right angles.
No, on that blue one.
No, there is. Let's start with the red one. For now, don't even look at the blue one. Look at the red one. The problem, oh, actually, let's look at the blue one and then go back to the red one. If I look at the blue one, I don't know how long this side is. So I have to figure out how long that side is. But if you look carefully, isn't that side of the blue one exactly the same as the side of the red one?
Yeah.
So what I want to do first is find the red triangle. So now I don't want you to look at the blue triangle. Now what I want you to do is only look at the red triangle. And I'm going to call this X over here, and here's my right angle. So there's my arrow drawn across, and that shows me that X is the what, everybody? What is X? What? The hypotenuse, very good. Okay, so we know that leg squared plus leg squared is equal to hypotenuse squared. And by the way, sometimes they say a squared plus b squared is c squared. If they say that, you have to realize that c has to be the hypotenuse. Every once in a while, they make a problem where they put c in where the legs are, and everybody gets it wrong. So instead, I prefer to just say leg squared plus leg squared is hypotenuse squared. So 3 squared plus 4 squared is equal to x squared. Now, what's 3 squared, everybody? 9. What's 4 squared?
16.
And x squared. And 9 plus 16 is 25 is x squared. And then I square root. And this is a nice, easy square root. X is equal to 5. So now, I'm going to go back, but I'm going to write the 5 in blue. And I had said yesterday when you come in the room, let's everybody grab a calculator. Not the ones in the big bucket, but in the little ones with the slats over there. Grab one of those each, because they're gonna come in handy now. Nice service. Okay. Now, I don't want you to look at the red triangle anymore. What triangle do I want you to look at now? The blue triangle. And again, even in the blue triangle, leg squared plus leg squared is hypotenuse squared. Now, I really like something Annabella said before. She said there's no right angle. And there is a right angle. Picture a rectangular prism. I don't happen to have, do I have one? Well, no. I have a box over here. I have a, oh, well, here we go. Here's a rectangular prism. Okay? What kind of angle is it down here?
Right angle.
What is every corner gonna be?
Right
Gonna be right angles. So, what I have is right here is a right angle joined to the hypotenuse. So,
Isn't the bottom a little slanted?
what you're dealing with is the base hitting here. So anytime the base, the horizontal hits the vertical, you're gonna get a 90-degree angle. So this is gonna be 5 squared plus 12 squared is equal to n squared. Now, what's 5 squared, everybody? 25. If you don't know what 12 squared is, you can actually do that on your calculator. There's 12 and there's an x squared button. So hit 12 and then the x squared button. You could also, of course, write 12 times 12 if you wanted to, but just to do 12 and then the x squared button, and it tells you what, everybody? 144 equals n squared. Now this is the same side situation, so we add them up, and I get 169 is equal to n squared. And now we have a bit of a problem, because most kids don't walk around with the square root of 169 off the top of their head. Maybe by the end of the year, maybe by the end of the month, but not at this particular point. So square root, square root. Now on your calculator, right above the x squared button, look on your calculator, find the x squared button, look just above it. See how it says in light blue the little square root symbol? So to hit that, the button above, you gotta go second. You see how in the upper left corner of your calculator it says second? So hit second and then the x squared button, that means square root. And then put in 169. And it should tell you 13. Okay? So now we can find out square roots that aren't the ones we always use. Okay? Any questions on that? No, we're good? Okay. So we know how to use the x squared button, we know how to use the square root button. We can see now how we could use 2 triangles to solve one really massive, ugly problem, and so on and so forth. Okay, let's go to the next question that we have to do as part of today's lesson sheet. And lo and behold, there's a graph there. So if I scroll down to that graph, let's have you plot the points 0, 0, and 3, 4. And once you plot those points, draw the line connecting them. How long is that line? Well, that would be the slope. That's a great way to look at it. That actually has something to do with how you get the answer. Okay. The truth is that just by looking at the line, you can't tell how long it is. All right. Like some kids, they'll look at this, but this distance here is 1. When I start sliding across a box, that's not exactly 1. Like that looks like maybe it's a 1, maybe, but then that one's shorter, and that one's shorter. And together they're on a diagonal. I don't know that a diagonal is exactly the same length as the side. In fact, I'm sure that the diagonal is not the same length as the side. So how can I solve this? And here's how we're going to do it. We're going to use the Pythagorean theorem. check it out. Ready? Draw a line straight down and then straight over. How long is this leg right here? Because obviously this is the right angle, right? How long is this leg right here? 3. How long is this leg? 4. Now, what kind of triangle is this? And what side is the line segment that I drew? It's a leg or a hypotenuse, guys. What side is it? It's the hypotenuse, right? Because it's right across from the right triangle. Now, use the Pythagorean theorem to measure how long it is. Listen, Pippi. Focus time, work time. And now we come up with that same red triangle that we had inside the rectangular prism before. If I do leg squared, which is 3 squared, plus what's the other leg? 4 squared equals what's the hypotenuse? X squared. 9 plus 16 is x squared. 25 is x squared. Square root both sides. Now this is one you probably don't need a calculator for, x is 5. But if you struggle on something like that, you could always use the calculator for it. Okay? Any questions? Now that was a nice easy one. Let's go to the next one, which is a little bit different. Go ahead, turn the page, get started on it, give it a shot, we'll go over it in a minute. Okay, 30 seconds or so. It's hiccups.
What button do you use for the
Square root. Do you see the second button on the upper left-hand corner? Then the x squared. Because you see how above the x squared is the square root?
You're talking about this one or this one?
That one. But you want to do second and then that one. See how above it there's the little square root symbol? That's why you got to do second. Anytime you use the one above, you always do second first. You know, people can complain if they want to in life, or you can just do the best you can in circumstances. Like I'm looking around this room, and I'm looking at some seriously full heads of hair. Right. I'm looking, Cheyenne's got some serious hair going on there. Lizzie, Talia, Gabby, Arlene, Michael, Middledorf. Birds can nest in Middledorf's hair. And then I look at me.
At least you're not as bad as my dad.
He's even worse.
Yeah.
Wow.
He's completely shiny like a
Cue ball,
Like a diamond.
like a diamond. Well, I'm gonna tell you, Dad, you call them a diamond. It's a beautiful thing, right?
My friends and me have a little joke. We say shine bright like a diamond.
There you go. Well, if my kids tell me I'm a diamond, I feel pretty good. All right, so I dropped the right angle down here,
Check round to that.
over to here, or dropped the vertical, I should say. And then the next thing I want to do is identify the hypotenuse. There's my right angle. Here's the hypotenuse. How long is this piece on the bottom? 3, good. And how long is this piece? 1, 2, 3, 4, 5, 6, 7, 8 it is. So now I do leg squared, 3 squared, plus leg squared, 8 squared, equals hypotenuse squared, I'll call that x squared. And I get 9 plus 64 is x squared. It's the same side, so I do the same operation. And then I get out my handy dandy calculator, and I square root it, and I go, huh? Because you don't come up with a whole number, right? This thing, the square root of 73, this is called an irrational number. It's called irrational because it doesn't have a perfect square root. If this was the square root of 64, that's 8. If it was the square root of 81, that's 9. But just as 73 is between 64 and 81, the answer has to be between 8 and 9. So it's actually going to be 8 point something. Now, if you hit your calculator, give me the first 3 decimal places. 8 point what?
5, 4.
5, 4, 4. Okay. Now, the directions will always tell you something like round to the nearest whole number. If I round this off to the nearest whole number, what's that answer? The nearest whole number? 9. What if it said nearest tenth? 8.5. What if it said nearest hundredth?
8.4.
No, 8.54, right? Because here's your hundredths place, and this says stay the same. So you just have to be careful. Sometimes they want you to leave your answer, square root of 73. It'll say leave in radical form. That's it. Square root of 73 is radical form. Radical form. Sometimes they will tell you to round it to the nearest whole number, round it to the nearest tenth, round it to the nearest hundredth, and so on. Then just pay attention to whatever they tell you to round it off to. Okay? All right, I think we got one more to do, or was that the last one? One more. Go ahead, do it. As soon as you're done, go to the water fountain. See if you can get rid of your hiccups. One of the things I think most kids tend to like about Pythagorean theorem is once you identify the sides, it's really mechanical and pretty predictable, so it's not very hard.
Do we round it?
Let's go with rounding it to the nearest tenth. Everybody hear that? We'll round to the nearest tenth. Okay, did everybody get the same thing? 2 squared plus 11 squared is x squared? We looking good, Gab? Good. I add them up, I get square root of 125. What does that work out to? 11 point, which if we go to the nearest tenth would be 11.2. Agree? right? 11.180, this is the tenths place, that tells me to go up 11.2. All right, any questions? Okay. Pythagorean theorem is, what does the Pythagorean theorem say again? Plus leg squared is hypotenuse squared. Good. Here, ready? X, Y, Z. Write the Pythagorean theorem using those three letters. What did we get, everybody? X squared plus what? Y squared equals what? Good, let's do this one. Remember, be careful of that right angle.
That's all I need.
Yep, what do we get on the next one, guys? A squared plus C squared equals B squared. Very good. Always equals the hypotenuse squared. Excellent. All right, start your homework.
What about the library weekend?
Okay, let me just stop the recording here, and then I'll look in my calendar and see what we got going on.